Good morning, one and all. So now let us start the last unit, that is fifth unit. So that is information theory and coding. So we study what is information and what is the different coding techniques we have for the information. Now, so here first of all let us see what is information. So information theory. So information theory makes extensive use of probability theory. So you must know very well about probability to understand the information theory. So that is a basic prerequisite to understand information is to know the probability theory. So now here we always use two terms. They are uncertainty and the information. They are very much closely related. So what is uncertainty? Or it's sometimes called as ambiguity. Okay. So and what is information? So let us take the following sentences. Okay. The first sentence is tomorrow the sun will rise from the east. Okay. So the moment you heard about this sentence, what can you say about the sentence? Okay. So we know that this is a universal truth. Okay. Which means so this event occurs with a probability equal to 1, or you can say that this is a certain event. Okay, that is sentence 1. Next sentence, let me take some other sentence, that is the phone will ring in the next 1 hour. Okay, so this is a second sentence. The third sentence is it will be cool in the Basar this summer. Okay, you compare these three sentences here. So the first sentence is having a probability of 1. It is a certain event. Why? Because it is a universal truth. Okay. So the second sentence having some more probability. It is not 0. So when it comes to last sentence, so usually it will be very very hot in the summer in Basara. Okay. But if I say it will be cool in Basara this summer means the probability of this third sentence is very very less. Okay. Now, so if you compare these three sentences, how much information do they give? Okay. Let us understand these three sentences in the context of information. What amount of information you get if I say the first sentence? You get a 0 information because you know this already. It is known to everyone because this is a universal truth. If I say something like this, the amount of information that you get from this event is 0 because it is known to everyone. Okay. So let us take second sentence. Yeah. So from the second sentence you may get some information. What about third sentence? So from the third sentence you get more information compared to the second sentence. So the reason is, so the amount of information that you get from any event is inversely proportional to the probability of occurrence of that event. Okay, so this is generally true. You take anything. Okay, so if something occurs very rarely, so from that event you get more information, which means that will be more interesting to us. Okay, you take anything in nature. If something happens with very very low probability, so that gives more information. So it is something like a news and a breaking news. So when it becomes breaking news, if something rare happens. Okay. So why it's called breaking news? Because it gives more amount of information. Okay. So if something usually happens, we don't get any more information from that event. Okay. You take any typical examples for this purpose. Okay. Now I taken so these three sentences to say something like that. So they contain different amount of informations. So in the first sentence, hardly there is any information, which means so there is no information at all. Okay. So yeah, the reason is it is a certain event and it is universal truth. So the first sentence is most probable and you get very least information. So the last sentence is least probable, it gives more information. So the occurrence of less probable event conveys more information. So that is very very important. Okay. So now let us see something called self-information. Okay. Now let us study in the mathematical perspective. Now I am taking a source capital S. Okay. Source S is a source capital S is emitting these symbols S0, S1, S2, so on, so on, Sk minus 1 at regular intervals of time capital T. Okay. So at each and every capital T seconds, this source capital S is emitting a symbol, namely S0, S1, S2, so on, so on, Sk minus 1 with the probabilities Pi. Okay. So what the probability of occurrence of S0? P0. S1, P1. S2, P2, so on, so on, Sk minus 1, Pk minus 1. Okay. So the source is emitting symbols at regular intervals of time. What are those symbols? S0, S1, S2, so on, so on, Sk minus 1. What are the probability of occurrence of those symbols? Pi, which means P0, P1, P2, so on, so on, Pk minus 1. Now it should be valid. Why? Because what is this? Sum of all probabilities is equal to 1. So the sum of the probabilities of occurrences of these k symbols should be equal to 1. So that is the probability theorem. Okay. Now one more thing we are assuming is, so the probability of occurrence of each and every symbol is statistical independent, which means so the probability of occurrence of any symbol does not depend upon the remaining symbols. So in that sense, all the symbols are statistically independent of each other, which means so the occurrence of one symbol will not be affected by occurrence of other symbols. Okay. Yeah. So as I told you just now, so the information is inversely proportional to the probability of occurrence of that event. Okay. Now, so this is what the information that we get from the occurrence of any event. We call I of Si. Okay. Here, what does this indicate? So the information gained from the symbol Si. Otherwise, the information that we get from the occurrence of symbol Si equal to log of 1 by Pi. What is Pi? The probability of occurrence of symbol Si. So the information is inversely proportional to the probability of occurrence. Okay. So that is very much evident from these three sentences. Okay. Now, so here, so let us see some properties of this information here. So if the probability of occurrence of event is 1, if Pi is 1, what is log 1 by 1? Log 1. What is log 1? 0. Okay. So if any event is certain, the information that we get from that occurrence of that event will be equal to 0. Okay. Now if it is from 0 to 1, this information is always positive, which means, so if the probability is from 0 to 1, obviously any probability always be in between 0 and 1. Now here, then what happens? The information will be always positive, which means, so from the occurrence of any event, you may get some information, you may not get any information, but there is no loss of information. So that is the meaning of this second property. What is the property? Information can never be negative. In the sense that, so if any event occurs, from that particular event, we may get some information, we may not get any information, but you don't lose any information. Okay. Now, so the third property is very, very simple. What do you mean by that? So if Pi is more than Pj, the information would be reversed. Si will be having more information compared to the Sj will be having more information compared to the Si. So this is from this property only. So the third property is what says? So the information will be inversely proportional to the probability of occurrence. If Pi is having more probability, means it gives very less information. Okay. Now, so the fourth property says, if the two symbols are independent, so this is I of SISJ, that is a mutual information, not mutual information, joint information I can say, that is I of Si plus I of Sj. So if Si Sj are statistical independent, so that we can write I of Si comma Sj equal to I of Si plus I of Sj. So that is also very, very simple. So these are some of the properties of the information or self information. It is called self information or simply information. Okay. Now, so here, so the formula of information is log of 1 by pi. Here I did not mention the base of the logarithm. Here I did not mention the base of the logarithm. It can be 2, 10 or anything. But so here what I have written here is, so generally we take a logarithm to the base 2. Okay. So that is a typical practice to take base 2 as a, to take base as 2 to the logarithm. Okay. Then, so if you take the base of the logarithm as 2, you must say that the units of information is bit. Then what do you say? The information, the amount of information is bit. Okay. You must call the unit of information is bit if you take the logarithm to base 2. Here, so we typically take the logarithm as base 2. If you do so, you must say that the information is in terms of units, in terms of bits. The unit is bits. Now this is what the typical formula of the information that we gain from the occurrence of any symbol SI. Now log base to 1 by pi. We also write minus log to pi. You know all these things. So these are the typical formulas that we use for the information. Log of base to 1 by pi, or that is also equal to minus log base to 1 pi, where I varies from 0 to k minus 1. Okay. Suppose if pi equal to 1 by 2, then what is I of Si? So 1 by 2 in the sense 1 by pi means 2. Log 2 base 2, that is 1. So 1 bit. Now if the probability of occurrence of any symbol is 1 by 2, then we gain a 1 bit information. Here I have written, so 1 bit information is 1 bit is the amount of information that we gain when the equiprobable event occurs. Okay, otherwise, so when the probability of occurrence of any event is 1 by 2, so the amount of information that we get from that particular event is 1 bit. So here the unit becomes a bit. Okay. Now here, so you must understand that, so it is a contraction of the word binary digits. You try to understand this very, very carefully. So what do you want to say is, suppose let's take, you take a binary word. In this word, there are 3 bits. Correct? So we say there are 3 bits. But, so these bits and these bits are different. Here, 1 bit in the sense that it indicates the amount of information, not the number of bits in the particular word. Okay. So you must understand this sentence very, very carefully. Okay. So here we see that there are 3 bits in a word. But here bit means the amount of information. They are not same. Okay. Please make a note of this. I told you already, information is always non-negative. It is always positive. Now, suppose if the probability of occurrence of any event is 0, then what will happen? So so P of I is 0, 1 by 0 is infinity. Log infinity is undefined actually. It is unbounded. Okay. Now, if there is any event whose probability of occurrence is 0, then the information will be unbounded. So which means we get infinity amount of information that is not bounded. Why? Because log of infinity is not defined properly. So if any event having a probability of occurrence of 0, now the information would be unbounded. Okay. So if the probability 0 means it is the probability, it will never occur simply. So if something never occurs, so from that the information will be unbounded. Okay. You take a simple example. So consider tossing of a fair coin. So you may get head or tail. Suppose if the probability of head is same as tail is same as 1 by 2 or 0.5, what would happen? Now if head comes, so how much information you get? 1 bit. If tail comes, again you get 1 bit information. So if you toss a fair coin whose probability of getting head is same as tail is same as 1 by 2, then the amount of information that you get by getting head or tail will be equal to 1 bit. Okay. Now, so that is about information or self-information. We denote with I, capital I of SI, which means the information gained from the event or from the symbol SI. Okay, whose formula is like this, and it has got some properties. These are some properties. Okay. Now, so let us move on to another topic, that is called entropy. It is very, very, very important. Okay, you take it as star. Very, very important. Entropy. Okay. Now, so here I will take a source. So what source? Capital S. It is emitting a symbol at regular intervals of time. What symbols it is emitting? S0, S1, S2, Sk-1 with the probabilities P0, P1, P2, so on, Pk-1. So these are probabilities of each and every symbol. And so what is this? I of S0 is what? Information gained from the occurrence of the first symbol whose probability is P0. What this indicates? Information that we get from the occurrence of second symbol whose probability is P1, so on, so on. Okay. Now, so what is entropy? That is called H of S. What is H of S called? Entropy. It is denoted as H of S. Now I want to find out the entropy of the source, capital S. How many symbols are there in the source? K number of symbols. A source contains K number of symbols, namely S0, S1, Sk-1 with the probability of occurrence of those symbols is P0, P1, Pk-1, and the associated information is I of S0, I of S1, so on, I of Sk-1. Now I want to find out expectation of the information over all probability values taken by the random variable S. Okay. I want to find out the average information of the source. Okay. Here I have the individual informations. But what is the average information of the source, or what is the expectation of the information over all probable values taken by the random variable capital S? Okay, here I want to find out expectation of I of Si, which means the expectation of information or average value of information. You know already what is if I say what is the expectation of X, let me write. If I say what is the expectation of capital X, what do you write? What is the formula you write? The formula is summation small x into the probability of x. Correct? In the same way, so I want to know what is the expectation of I of Si. What I write? Pi into I of Si. The probability into information. Now here, what is I of Si? What is the formula of I of Si? This is the formula of I of S. Substitute here. Log base to 1 by pi. Pi into log base to 1 by pi. Summation I equal to 0 to k minus 1. Why 0 to k minus 1? Because this source capital S contains k number of symbols. Now this is the formula of entropy of the source capital X. Either this formula or this formula. So please make a note of these formulas of entropy. So here what entropy means? It is a measure of the average information content per source symbol. Okay, so what is the average information in the source symbols? See, so if I take expectation, generally I get average value only. Okay, so expectation means average value only. So entropy means average information of the source. Here H of S means average information of the source capital X, which contains k number of symbols. Now please make a note of this. This entropy depends upon what values? What values? The probabilities. So the entropy of any symbol or the entropy of any source depends upon the probabilities of occurrences of individual elements or individual symbols in that particular source. Now there is no other variable except probability. Pi into log of 1 by pi. Okay, it completely depends upon the probability. Now, so please write this. It is a measure of uncertainty. Entropy is a measure of uncertainty. It measures the uncertainty. How much uncertainty is there, or it measures amount of ambiguity. Uncertainty means not certainty, not certain. Okay, we are not sure. Okay. Now we have borrowed the term entropy from the statistical mechanics. So from that we borrowed this term entropy. Now, so here entropy of the discrete random variable capital X is bounded as follows. Please put this point. Note this point, all of you. This defines the bounds of the entropy. Bounds in the means the minimum value and the maximum value of the entropy. Now what is the minimum value of entropy? 0. What is the maximum value of entropy? Log of k base 2. What is k? Number of symbols in the source alphabet. What is k? What is k? The number of symbols in the source capital X. Here it has got k number of symbols. Okay. Now you are finding the entropy of the source, which contains k symbols whose probability of occurrences is P0, P1, P2, so on, Pk minus 1. Now for that source, the bounds of the probability, the bounds of the entropy is 0 to log k base 2. It lies between these two values. Okay. Now when the entropy will be 0, you go to the probability of entropy. When it will be 0, you guess. When it will be 0, I am just simply asking. When this answer will be 0? When P of I equal to 1. If P of I equal to 1, what will happen? 1 into log 1 base 2. What is log 1 base 2? 0. So everything will be 0. But if P of I equal to 1, what do you mean by that? The occurrence of the ith symbol is 1. What do you mean by that? Let me tell you the importance of this. Yeah. Here. So here P of I is 1. I am asking only P of I is 1. Summation of P of I anyway it will be equal to 1. But I am not taking summation. I am simply saying P of I equal to 1, which means the probability of occurrence of symbol Si is 1. What is Pi? The probability of occurrence of symbol Si, which means here, so the symbol Si is a certain symbol, means that symbol occurs for sure. That is compulsory, that is obvious. The symbol Si occurs definitely with the probability 1, which means remaining symbols probability is 0. Okay, you know all these things already. Suppose if I say that there are 10 symbols, one symbol is having a probability of 1. What about remaining symbols probability? It has to be 0. Why? Sum of all probabilities is equal to 1. Okay. So if any one symbol occurs with a probability of 1, obviously remaining symbols they don't occur, which means the probability of occurrence of remaining symbols is 0. Okay, so this symbol is called certain symbol, or it is a sure symbol. Okay, I hope you know these things already. Now, so here so the entropy will be minimum, that equal to 0 when p of I equal to 1, which means the source emits symbol Si with a probability of 1. Okay, but we know that the source definitely emits symbol Si, means there is no uncertainty. So the symbol is certain because it has got 1 probability, or it has got 100% probability. If something happens with the probability of 1, we say that is certain, that is definitely will occur. Now in that sense, there is no question of having uncertainty, there is no ambiguity, there is no confusion at all. We are very much sure that that symbol will occur with full probability. Now that's why entropy is 0. Why? Because there is no uncertainty. I told you, it measures uncertainty. If there is no uncertainty, there is no entropy, means that is 0. Okay. Now, so this is what explanation. So let us take the following set of probabilities of a discrete symbol. One symbol is having a probability of 1. Obviously, remaining symbol should have a 0 probability. Now, if it is so, you get entropy 0. You go with these calculations. Is it okay, all of you? So I told you already, you must know some probability theory to understand the information theory. Okay. Now, so when it is maximum, when the entropy is maximum, what is the maximum value? Log k base 2. When it occurs? When the probability of pi equal to 1 by k for all k, which means when all the symbols are equiprobable. Here in the source capital S, we are having how many symbols? How many symbols? K symbols. If all the symbols occur with same probability, now the probability of occurrence of each and every symbol will be 1 by k. I hope you know this at least. Okay. Now the probability of occurrence of each and every symbol is 1 by k. So P naught, P1, P2, so on, so on, Pk minus 1 equal to 1 by capital K. Okay. Now then what happens? You take this simple example. Suppose if all the symbols are equiprobable in a source, otherwise if a source emits symbols with equal probability, suppose it is emitting k symbols, the probability of occurrence of each symbol will be 1 by k. Then what happens? So these are all the set of probabilities. Now what is the entropy? Pi log base to 1 by pi. What is pi? 1 by k log k base to, plus 1 by k log k base to, so on, so on. Okay. So you try to find out this. You get log k base 2. That is the maximum possible value for entropy. Okay. Now what is it indicating? What does this indicate? It indicates there is a maximum amount of uncertainty. There is a maximum amount of ambiguity. Okay. So otherwise we are not sure. Okay. Which symbol is emitted. Now you take simple example. Okay. Suppose you are tossing a coin. Simple example is tossing a coin. You toss a coin, you may get head or you may get a tail. Okay. Suppose, so the probability of getting head is same as tail, that is 1 by 2. Or so the probability of getting head is same as tail. Otherwise, so these two are equiprobable. What a probability? 1 by 2. So in that scenario, there will be maximum amount of uncertainty because we don't know what might be the outcome of the experiment. You're tossing a coin. We are not sure whether you get a tail or head because both are equiprobable. If it is a fair coin, if you toss it, so the probability of getting head is same as tail. So now we are very much interested to know the output because nobody can guess the output. because both are equiprobable. So if nobody can guess the output, there is more amount of uncertainty. So which means there is more entropy. Entropy is nothing but uncertainty. Okay. So let me take reverse situation where head and tail. So the occurrence of head is 1. Obviously the occurrence of tail is 0. Okay. Which means, what do you mean by that? So the outcome is well known to us. If I toss a coin, everybody knows that it's going to be head. Now, so there is no uncertainty now, because we are sure output will be head. So there is no uncertainty. We don't bother about outcome, at least. We know, everybody knows that output will be head because it has got one probability. Now there is no uncertainty. Okay. So you try to understand these things with an example. You take your own examples. Okay. So not only here, everywhere. So you take cricket match. Okay. So if there is a match between two strongest teams, okay, what will happen? So the probability of winning team A is same as winning team B. Then so people are very much interested to watch the match. Okay. So you take an example. Okay. So you take an example of IPL also. So if there is a match between two strongest teams, so the probability of winning team 1 will be same as team 2. Then it gives more information. There is more amount of uncertainty, isn't it? Suppose if there is a match between two, top team and the bottom team, we are not interested about that match also, because mostly we know that the top team will win. Okay, there is no much uncertainty. Okay. Now, so here this is about the limits of the entropy or bounds of the entropy. It is from 0 to log k base 2. It lies anywhere between these values. Okay, right. You take the example and solve it. Okay, I told you the answer also. So this is one example for you. Please solve it. So we stop here.